I'm going to discuss hydrocarbons, and these are substances contain only carbon and hydrogen atoms. All that we know that carbon contains 6 electrons. In the first energy shell, it has 2 electrons. In the second energy shell, it has 4 electrons. So, in the last energy shell, they have the carbon atoms is surrounded by 4 electrons, so it needs another 4 electrons to share and to make a 4 covalent bond, and finally we have a methane molecule. So this molecule is called methane, where the carbon is surrounded by how many bonds? 1, 2, 3, 4. This, the way showing the bonds, we call it structural formula, and we call this molecule methane. So methane is the first member in a homologous series called alkanes. Alkanes are molecules, they are saturated. They are mainly molecules containing only carbon and hydrogen. They are hydrocarbons compounds. And the first member is methane. So if it contains 1 carbon atom, it is called methane, and the molecular formula is C, and we count how many hydrogens. The second molecule in alkanes, in the saturated molecules, where the functional group or the bonds between carbon and carbon is single bond, no double bond. Because of this, they are called saturated. We call ethane. Ethane means 2, 1 and 2. And each carbon atoms will be surrounded with 4 bonds. 1, 2, 3, 4 in common with the other carbon atom. 1, 2, 3, 4. So the ethane has 6 hydrogens. If we need to get the molecular formula, we are going to count how many carbons? 2. And how many hydrogens? 6. Then we come to the propane. If we have 1, 2, 3 carbons, each carbon will be surrounded with 4 bonds. 1, 2, 3, and the fourth with the common. 1, 2, 3, 4. 1, 2, 3, 4. So each carbon atom will be surrounded with 4 bonds, hydrogens atoms, and we call them propane. Propane means 3, 1, 2, 3, and the AN is coming from the alkane homologous series. And the molecular formula, we're going to count how many carbons? 3. How many hydrogens? 8. Showing the bonds is called structural formula. If we have 4 carbon atoms, 1, 2, 3, 4. 4 means butane according to the family alkanes. Also, they are saturated compounds. There is no double bond between the carbon and carbon, no double bond, single bond only. Each carbon atom will be surrounded with 4 bonds, 1, 2, 3, 4. And the second one, 2 in common and 3 and 4. The carbon, 2 in common and 3 and 4. The last carbon atom will be 1 in common and 2, 3 and 4. If we want to get the molecular formula, we are going to count 1, 2, 3, 4 carbon atoms, and how many hydrogens? They are 10. We move to the 5 carbon atoms. It is called pentane. Pentane, it's in the family of alkane homologous series. They are saturated compounds, no double bond, single bond as a functional group. And each carbon atom will be surrounded with 4 carbon atoms. 1, 2, 3, 4. And the second one, 1, 2, 3, 4. The third one, 1, 2, 3, 4. The fourth one, 1 in common, 2 in common, 3, 4. The last one, 1 in common and 2, 3, 4. We call this structural formula showing the bonds, and if we want to get the molecular formula, we're going to count 1, 2, 3, 4, 5 carbon atoms and 12 hydrogen atoms. Now the alkanes homologous series, they are saturated compounds and they have same general formula, CnH2n plus 2. They have the same functional group. They have the same chemical properties. If we are talking about the general formula, CnH2n plus 2, the n means number of carbon atoms. If we know that carbon atoms 2, we have to substitute like algebra, 2 times 2, 4, plus 2, 6. So we can get any number of hydrogens if we just know the number of carbons. So if we have 5 or 6 carbon atoms, we're going to substitute how to know how many hydrogens we're going to get. 2 times 6, 12, plus 2, 14. So here, if we're going to show up a structural formula for hexane, C6, how many hydrogens we're going to show? Bonding with the carbon atoms, 12 plus 2 is 14. So in the general formula, we can deduce the number of hydrogens if we know the number of carbons. The second homologous series is called alkene, and alkenes also, it's a substance contains double bond between the carbon and carbon. They are unsaturated because they contain the double bond carbon and carbon. The first member is ethene, and each carbon atom will be surrounded with 4 bonds, 1, 2 in the double bond, 3 and 4 for this carbon atom. The same for the second carbon atom in common double bond, 1, 2 and 3 and 4. This is showing the structural formula. In order to get the molecular formula, we're going to count C2H6. The second member is propene. Also, it is in alkene homologous series. It contains 3 carbon atoms, 1, 2, 3. Now we have 2 ways to draw the single bond, either between the first and the second carbon, it is propene, and we're going to show the bonds 1, 2, 3, 4. The second bond 2 in common, 3, and the fourth will be up here or down, it's the same. And the third carbon atom 1, 2, 3, 4. We can draw it like this, or we can draw this double bond between the third and the second like this. It's the same propene. And we're going to show also the bonds, hydrogen, hydrogen, 2 bonds, 2 in common, 2, 3, 4, and the last 1, 2, 3, 4. It is propene, 3 carbon atoms and 6, 1, 2, 3, 4, 5, 6 hydrogens atom as a molecular formula. Let's move to the butene. The butene differ because here we have the double bond could be between the first carbon atom and the second carbon atom, and it has another structural formula. I can draw it between the second and the third. So in the first, if I draw it between the first carbon atom and the second carbon atom, that means that I'm going to show the bonds up and down, 3 and 4. For the carbon atom, 1, 2, 3 and 4. For the third carbon atom, 1, 2, 3, 4. For the fourth carbon atom, 1, 2, 3, 4. So how we name this compound? It's called butene. Butene because it contains double bond. But the double bond between which carbon atom? Between the first and the second. So we're going to say 1 butene, or we can write butene 1-ene. But 1-ene. Why? Because we have another structural formula to draw butene, which is drawing this double bond between the second and the third carbon atom. Now here the compound will be different. We have another compound called 2-butene. Why? Because if we consider this the first carbon atom 1 and we count from this direction, so 1, 2, 3. So the double bond between the second and the third carbon atom. But the same if we count from this way. So if we choose to count from this way, we're going to consider that this carbon 1, 2, 3, and 4. Also the double bond will be between 2 and 3. So also the same, this compound is called 2-butene, and it is different between 1-butene and 2-butene. So 1-butene, the double bond between the first carbon atom and the second. 2-butene between the second carbon atom and the third carbon atom. Alkene also have, all alkenes have same functional group, which is the double bond, and they are unsaturated because they have between carbon and carbon double bond. Here the general formula different. It is CnH2n. This is the general formula for alkene. N is the number of, if we consider that the N is the number of carbon, we can get the number of hydrogens. If carbons is 2, so the hydrogens are 4. If the carbon is 5, so the hydrogens will be 2 times 5, it will be 10. So it is easy to get by the general formula, if we know the number of carbons, to know how many hydrogens will be bonded. Now let's move to the third homologous series, which is called alcohols, which are substances containing functional group OH. And the general formula is Cn plus 1 OH. N is the number of carbons. In the first member of alcohols, it's 1 carbon. It will be bonded also with 4 covalent bonds. 1, 2, 3, and the fourth with the functional group OH. So OH is the hydroxyl functional group. It's called hydroxyl, and the first member is meth because 1 carbon and all for the alcohol. So methanol. Let's move to the second member in alcohols, which is called ethanol. Ethanol, it's 2 carbon atoms. Each carbon atoms is surrounded with 4 covalent bonds, and the second carbon atoms will be bonded to the functional group OH, which I know from it that this structural formula for alcohols because it contains the functional group OH. So if you are asked to draw a ring on the functional group, so you're going to, for the alcohols, you're going to draw for the OH. If we want to get the molecular formula, we're going to count C2, H5, 1, 2, 3, 4, 5, and OH is the functional group. We can write it like this as a molecular formula. Now we have the third. If they are 3 carbon atoms, 1, 2, 3, each carbon atom will be bonded with 3 bonds, and the fourth common with the other carbon atom. And we have here the carbon atom connected to the OH functional group, which is the functional group for alcohols, and we call this structural formula propanol because they are 3 carbon atoms. 3 means propanol. Here we have to know the OH is bonded to what? To the first carbon atom or the second carbon atom or the third? If it is connected or bonded to the first carbon atom, we call it propanol, 1 propanol, all propane, 1 ol. And if it is bonded to the second double bond, this compound will be called 2-propanol or propan 2-ol. So if I have the functional group bonded to the second carbon atom, it is 2-propanol. If it is bonded to the first carbon atom, it is called 1-propanol. And this compound differs than this compound. We have butanol. But means 4, 1, 2, 3, 4. And the OH will be bonded to one of the carbons. So if it is bonded to the first carbon, it is called butanol. If it is bonded to the second carbon, it is called 2-butanol or butan 2-ol. Let's move to the other homologous series, which is called organic acids. The organic acids contain C double bond OH as a functional group, and it has a general formula CnH2nO2. The first member in organic acids if we have one carbon atom. As we know, methane is one carbon, means one carbon, and we're going to add OiC. So methanoic acid means one carbon. It has four carbons, showing four carbons. 1, 2, double bond O, and all these are considered the functional group of the carboxylic acid. So if you are asked to ring the functional group for the organic or the carboxylic acids, it's C double bond OH or COH. We can write it like this, COOH, or as showing the bonds H, C double bond OOH. The second member in carboxylic acids is ethanoic acid. It is mainly two carbons. The first carbon is bonded with 4 hydrogen atoms. The second carbon is bonded to the functional group C double bond OOH. We can write it like this or like this. And if you are asked to ring, also we're going to show that we can draw the ring around the functional group COOH, which is the functional group of the carboxylic acid. We have another title in this topic. We have isomerism. Isomerism is they are organic compounds have same molecular formula but different structural formula. If we have alkenes C4H8, 1, 2, 3, 4. So they have 4 carbon atoms. And here another structural formula 1, 2, 3, 4. So they are C4H8. 1, 2, 3, 4, 5, 6, 7, 8. So this one has C4H8. 1, 2, 3, 4, 5, 6, 7, 8. And that one has also C4H8. So they have the same molecular formula. But as we know here, they are different in structural formula. Why? Because the double bond here between the first carbon atom and the second carbon atom. And here the double bond between the second carbon atom and the third carbon atom. So their names are different. Here we call this 1-butene because the double bond between the first carbon atom and the second carbon atom. And here we call this compound, here the carbon 1, 2, 3. So the double bond between the second carbon and the third carbon we call 2-butene. We get the second, the least number according to the IUPAC system, 2-butene. Means that the double bond between 2 and 3. These two molecules are called isomers. Why? Because they have same molecular formula, means the same number of carbons and the same number of hydrogens. But they have different structural formula. Here the double bond between the first and the second, so we called 1-butene. And there is another compound called 2-butene, which is the double bond between the second and the third. So we call them isomers. Another example for the alcohol, which is butanol. Butanol here, it has the same molecular formula. Let's count how many carbons. 1, 2, 3, 4. So they have 4 carbons. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9. So they have 9 carbon, 9 hydrogens. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So they have 9 hydrogen atoms, OH. Let's count this molecule. 1, 2, 3, 4. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9. So they have 9 hydrogens here. And how many O and OH? So let's see they have the same molecular formula. The number of carbons and hydrogens are the same. But is the structural formula the same? Let's see. The OH here is bonded to the second carbon. And here the OH is bonded to the first carbon. So we call this 1 butene, and we call this 1 butanol, and we call this 2 butanol. So if we have the same number of hydrogens, so excuse me, it's 9 hydrogens and OH, the same molecular formula, but we call this compound 2 butanol. Why 2? Because the OH is bonded to the 2. So one of you asked me why we didn't count from this direction. Because if we count from this direction, 1, 2, 3, it will be 3 butanol. According to the IUPAC system, we take the least number. So in this direction, give me 3, but when we count from the left to the right, it will be 2. So always we take the least, 2 butanol. We don't say 3. And here it is the first carbon, 1. We don't take 1, 2, 3, 4. We take the least. So here it is butane 1-ol. So these are isomerism. Why? Because they have same number or same molecular formula and different in structural formula. Thank you.